along with the title of Best E-Learning Company of the Year 2022 by Business World Magazine. I'm happy to welcome our guest, Karudaiyar Ganapathy sir. He is the technical specialist at Robert Bosch.
As they have introduced, myself Karudaiyar. I'm currently working in IoT. I have done UG in Electronics and Communication and Master in Embedded System and MBA in Technology Management. So having around 9+ years experience in IoT, machine learning, and automotive electronics and other embedded areas. So the today topic which we are going to discuss is industrial approach to IoT and its research challenges. So why we are taking this particular topic? And guys, whenever you have a questions, you can immediately interrupt me and you can raise your voice. We will discuss. Okay. So the industrial approach is nothing about IIoT. So industrial IoT. First we have IoT, and we can use the IoT for the multiple applications. Today in our discussion, we are going to take application of industry. So industry, you are very well knows about it. We have so many industry in the world. So whatever the product you are seeing or you are using it, everything is coming via industry. We have a manufacturing industry. We have so many industries. So that's also one of the topic. And another thing is what we are going to discuss about is what are the research challenges we have when you are going to pick IoT for your product or your service areas, or in your future, you are an engineer now, you are going to use IoT in future. What are the challenges generally we have at that, how you have to overcome? That's also we are going to discuss in this session. Okay, so we no need to waste of our time. We can directly dive into start to think about what is IoT. So might when you are thinking or searching in Google, you are getting a lot of answers. Something is very complicated. Something you feel that, hey, what is this definition? I really didn't understand. Such a kind of mind thought you have it. I will make it very simple. See, IoT is nothing about, now we are connected via this session. How we connected via this session. So how I am interacting with you. I'm sitting somewhere, you guys are sitting somewhere, and Technobrain guys are sitting somewhere. So everyone are sitting different places. How we all connected together, that's because of internet. That's what exactly IoT also. So we all are objects. So we all are connected via IoT. So we are connected via internet, and we all are started to discuss each other. And we also human. That's what exactly IoT means about it. That's what exactly about Internet of Things. We all are things. We all are connected via internet, and we can able to make a communication between us. You can imagine the same thing happens for your object or your industry car, or some other object is started to your mobile phone or something, your antenna. So that's there. They doesn't want a human intervention. One mission can talk to another mission without human help. That's what exactly IoT is coming in the picture. You can think about it. You have a camera, secure camera, that is taking a feed and giving it to your hard disk or some of the microcontroller. So they are communicating each other. No human is sitting in between. If you are want to connect with a sensor, no one is sitting inside. That's what exactly IoT. Okay. So things communicate in the real time over the internet. In IoT, we have three kind of types. One is industrial. That's what we are going to take today. And another one is consumer. And third one is mission to mission. Mission to mission is nothing about, just think about it. Your car is going to communicate with another car to take some decision. Or they want to talk each other. And finally, they have to come to the decision perspective. That's what exactly about the M2M communication. Okay. So IoT is nothing about whenever you are connecting objects via internet and you are allowing them to communicate without human intervention. That's called IoT. Okay. I hope you have clarity now. Right. So what are the general examples we have in IoT? You can take a smart home. That's a very best example for IoT example, and smart industry like industry 4.0, 5.0, after involvement of machine learning. Now everything is completely handled via internet, right? All the data we are pushing to internet. So whenever there is no internet, we cannot push the data. And you are communicating, you are checking, you are sending a WhatsApp message. That happens via internet. Everything is happening via internet. Okay, without internet, nothing happens. So that's the best example for IoT. Okay, so okay, how big IoT it is? Exactly. So how many devices we connected by IoT? I really don't know. meaning whether you knows about this, how many devices connected or not. In according to the survey, in 2020, we have connected 4.4 trillion gigabytes of data in 2020 itself. But now we are in 2024. Might we have connected like more than 50 billion devices in the world. Now total IoT devices are there. Then think about how many amount of data we need to send it to via cloud, and how many amount of data we need to really use it for the communication. That's everything is happen via IoT. Okay. What are the main components we have in IoT? Because first you have to understand the IoT, then we'll directly jump into the industrial IoT. Then once we discussed about the industrial IoT, then we'll discuss about the challenges and other approaches. Okay. What are the main components of IoT? One is sensor. Which sensor? You want to think about it. You want to know about whether gas leakage is happening in your home or not. Okay. Then that sensor is connected with the microcontroller device. The microcontroller device is from ESP8266 or ESP32. Might you know about a very small microcontroller device? Think about it. You have a sensor that is connected with your microcontroller that is sensing. That means the particular microcontroller is taking a data from sensor, and the microcontroller has a Wi-Fi connectivity. That's what the connectivity. So now we need another component is connectivity. Connectivity is nothing about internet. So the microcontroller is collecting a data from sensor, and with the help of connectivity, the data will be pushed to cloud. There we will do the data processing. What do you mean by data processing? We will segregate the data, and from there you will have an Android app. There you will create a user interface. That's these are the components needs to be involved in the picture of IoT. Okay, so sensor, internet, cloud, then your application. These all are required. When the normal sensor is connected with your Wi-Fi chip, that time it becomes smart sensor. Okay, so the word when it comes smart, automatically it's because of IoT. I'll give one more example. Nowadays, whenever you want to go, you are simply booking a cab, Ola or Uber or other taxis, right? So how it is exactly happens? Are we changed our autos all everything to smart, or are we changing the setup of our autos? No. What we did, we bring the internet inside the auto. How we bring the internet inside the auto? Because we kept our smartphone inside the auto. Automatically your normal auto becomes smart auto. Then you can easily get it where the auto guy is there. That means where the pickup person is there. That particular guy can easily identify from where you booked, from where he needs to drop you. How it is exactly happened in these days? This is happened with the help of IoT, Internet of Things. Because we introduce the internet via your smartphone. There you have a cellular. Cellular is your SIM card. And from there, you are getting a Wi-Fi connectivity from Jio or your Airtel. Those are the network providers. So everyone are connected via internet. Then automatically your auto is talking to you, your smartphone. You are booking your cab. Just says that, hey man, I'm here. Can you come and pick me? Then the particular auto guy is coming and to the exact place where you are standing there, and he knows it where you need to go. These all are the things are happening. That's the benefit of IoT. Why this has happened after 2015 only? Because there only we started to use IoT. Before in 2010, ask about your parents whether can they book anything, because earlier they had a fast track. They have to make a call and they have to book it earlier to say that, hey, I want to go from here to there. The fast track, that time it was very famous those days. But later, with the help of IoT, Ola, Uber guys are entered into the market, and they started to actually easily approach the customers with the help of IoT. Okay, that's what these all are the components is really required to say you are in IoT. Okay, clear? Right. So what are the main functions we have in IoT? Function is you have to collect the data from sensor and you have to push the data to cloud. The cloud, you can send it via Wi-Fi or you can send it via 4G, 5G, because currently we are moving to 5G, right? And there in cloud, you need to use a cloud computing to do the analysis, whatever the data you have received. So then finally you have to take action. Action is nothing about in your app, you have to bring it and you want to switch on your light in your home. You can think about your smart home and you want to switch on your AC while you are sitting in the, and you want to switch on your TV and you want to do everything, right? In the case that is called as an action. So these all are the main functions of IoT. Don't take any IoT example from anywhere else. Every day you are using IoT. Every day you are living with IoT. You no need to go for, hey, how when vehicle is communicated to another vehicle. Hey, they have used in the Fast and Furious movie. No, you don't need to take like that. You can always take from your everyday example. Okay, you got it, guys? What is the main functions of IoT and what is IoT? Guys, if you have any question, please ask me in between. But you can also discuss with me in the end. But in between for basics of IoT, if you have any questions, please raise it. If not, we'll move to the next. Okay, right. So how exactly IoT works? For if you want to say, hey, IoT is working in such a way. So that's how exactly. How does IoT work? Okay, what is the working principle of IoT? IoT. So there is a three process. As same. Collect the data from your sensor. That's via IoT gateway or your framework. Send the data to cloud via wireless communication. From there, bring it to mobile app. So when you are taking about sensor, you can take example of temperature or humidity or pressure sensor, motion sensor, and you have many sensors. Gas sensor, whatever the purpose you want, you can actually take it, the sensors. Okay, and you can send the data to cloud with the help of IoT gateway. There are so many IoT gateways are there. So many IoT framework also there. For framework is also there. Or you can create your own framework also. So there are so many IoT framework is available ready-made in the market. Okay. So every framework has set of protocols. They have a tool support and they have a standard. Okay. Getting? And you have a open source IoT framework and you have a many. So based on that, you can use it. So if you want to know, so can you say some of the example of your IoT framework? Might you know about the car platform? That's also one of the one. And you have that is working in another way. And you have a device Hive. Might you know about it? And Zeta server. That's also, and ThinkSpeak is a very famous one. You know about the ThinkSpeak, right? That is also one of the IoT framework. And you have a MainFlex and you have a Thinker.io. Those guys are also coming in the part of IoT framework. Okay, that's called as IoT gateway also. So once the data is comes into the cloud server, that means your cloud, there you need to apply a cloud computing. From there you need to bring the data to your mobile app. So if you are from a EC background or a triple background, you will sit in the sensor side. You are coming from EC or CSE background and you will sit in the IoT framework. And you are from CSE or IT background, you will sit in the cloud server and mobile app side also. So this is the way your IoT works. But we have to discuss many deeper, but we don't have a really a lot of hours. We have only 1 hour to discuss about this topic. So I'm not going much deep dive into every topic. I'm just saying about what are things are there. So if you have questions, you can ask me, or after the session also, you can actually study about that. Okay. And later point of view also, you can come to us and we can discuss about that. Okay, right? Perfect. So why we need to really care about IoT? So you know about IoT architecture. Why we really need to care about the IoT? Because without IoT, these days nothing will happen. Okay. For an example, whenever your device want to send the data or receive data, then you need a smart device. So without smart device, our life will be difficult. You can think about your smartphone. So if suddenly industry says, hey, your smartphone will not work for 5 days, then think about it, how much our generation will get frustrated. Okay, you're getting the point, right? So we cannot skip IoT anymore. So sensors and actuator. Sensors and actuator is nothing about normally where you are collecting a data. That's what exactly about your sensors. For an example, I can say that you can take example of car. That example only I took. These days we are using IoT inside the vehicle also. You can think about, you have a gyro sensor, you have a tire pressure sensor, you have a wing position sensor. These many sensors, so many sensors are there inside your vehicle. So, and we have actuator also to control your motor, everything. And all the things needs to be communicated via internet to push the data to external world. You can think about now you have a car. Okay. You have given your car to your friend and you want to monitor where your car goes. And this, what is the speed of your car right now? And you are saying your friend, hey, this is my favorite car. Don't drive more than 100 kilometer per hour. Might you will end up with some problem or accident. So then still you want to monitor your car because your friend took the car. In the case, what you will do, obviously you need IoT. There exactly IoT comes in the picture. And there is a problem is happening in your car. Their car wants to talk to your service center guy, has to say that, hey, I will end up with a problem. I want to meet you. Such a kind of message. See, this is for vehicle. You can think about your body. Your body temperature is getting increased like anything. And you have a Fitbit. And your Fitbit want to talk to your personal doctor. There you need IoT. So all other places you need an IoT. Okay, you getting the point? This is a way IoT start to work. Right. Now about gateway. So gateway is nothing about a framework. That's what we discussed. So here for sending a data, if you really want to know, you can use a cellular, you can use a Wi-Fi, you can use a LoRa, and you can use a Ethernet. So gateway is nothing about receive the data from your sensor network and performs filtering and cleaning. That means it can filtering or it cannot unfilter also, but depends on your need. And it will send the data to communication to your cloud. And finally, the data will be in the cloud. Here you are using a edge computing and all that we will discuss in the upcoming slides. Okay, this is a purpose of gateway. So gateway will receive the data from your sensor and it will perform pre-processing and it will filter and finally the data will be in cloud. Guys, one thing only you have to remember where exactly you can stand in IoT architecture. That's what I clearly explained you. So if you are from a EC or a triple E background, you can work in a sensors and microcontroller also. You have a plenty of microcontroller. Yeah, you have a microprocessor also like Raspberry Pi, BeagleBone board. And nowadays, if you want to work with IoT, sorry, artificial intelligence and machine learning, you have NVIDIA. You have a lot of chips in market available in the market. Okay, so for collecting all the data, you need to sensors need to be connected with the microcontroller. So from there, data will be pushed to your IoT gateway or IoT framework. From there, data will be pushed to your cloud server. So in the cloud computing, you know about the software as a service, platform as a service. You have a many topics for cloud computing. So if you are from a CSE background, you can work in the IoT side in the cloud computing. So when you are from a CSE and IT background, and if you want to develop a Android app, then you have to use a mobile app. Okay, and here you can use anything. Even MIT app and also you can use. Okay, right. Now cloud server is nothing about, you already knows very well knows about it because everyone are these days we are using a cloud. So there you have a plenty of cloud and there is a topic of cloud computing also. Okay, right. Right. So cloud computing is nothing about, you can see all analytics, decision making, everything will happen in your cloud. The client gateway will push the data to your cloud. Cloud is nothing about Microsoft Azure and Amazon Web Services, Google IoT, IBM Watson. Have you worked on IBM Watson? It's one of the best cloud. You can actually try it. Guys, if you want to really learn it, IBM Watson is one of the best thing. And you can use a cloud, Google IoT also. Google IoT, Firebase, many are there. And you can use a Cisco IoT Cloud Connect. You can use the ThingsBoard IoT Cloud Platform and Oracle IoT also. Okay. So cloud is nothing about, it says about internet. Okay. Cloud computing means it's internet based computing like server, storage, and applications. Everything is part of your cloud computing. Clear, guys? So if you want to exactly, you know, you have a cloud provider and cloud user, and finally you will have a system software as a service user. So like software as a service provider and software service user. Cloud provider is nothing about your storage mechanism, where you are storing maybe you can CPU or warehouse, and provider is web and SaaS user. That means those guys all are like us who all are sitting in front of the computer. and who all are using it. Okay, clear, right? So you have again, you have a lot of clouds. That's I have mentioned it here. So this is a way your cloud computing will work in IoT, right? So mobile application is nothing about your Android app. You can right now keep in your mind. So data is in cloud, and you want to see everything in your Android app for taking action or decision. That's called as a mobile application, and you can keep it in a graph form, bars, or pictorial diagram, and user friendly manner, whatever the way you want, you can just keep it. Okay, clear guys? So currently everyone have app. What's the reason? Because if for example IoT relevant, if you want to monitor something or you want to take some decision for somewhere, then you need to keep it in a mobile application. So very well famous one is Android app. Okay, right. So this is one simple example. I really want to know. I want to say to you how IoT is working in electric vehicle, because that is means in automotive industry. Since we have taken industry, you can take any, but you all are might very well knows about electric vehicle things, right? So how exactly IoT plays a role inside your vehicle? So how exactly the things will be taken care in the automotive manufacturing industry? So the thing is, you have electric vehicle. Here it will be connected with a lot of sensors, and inside you will have a eSIMs. eSIM is like about SIM that will be connected to the cloud. From there you can monitor everything. Here, this technique is called as a edge intelligence. It's called as edge computing. Okay, you can call it as whatever the word name you want. And you can finally, the car has connected with the cloud always, and it will push the data to cloud that will be available in your manufacturer app. So when you are buying a car, they will tell you to install their app, and you can monitor everything there. Okay, and you can take any action, and you want to control your vehicle for some applications, that's also you can do. Okay guys, now in the industrial IoT is called as IIoT. There, what kind of technology or topic majorly used? That's called as edge intelligence. Okay, that's called as edge computing. Clear? So edge is nothing about autonomously, you can autonomously own and executed. Clear? You can think in a way, mobile can be called as a edge in the telecommunication field. Car or vehicle will stated as a edge in the automotive side. That's called as edge computing. That means autonomously own and executed. It's a word called edge. So think about when you are taking industrial IoT for your vehicle or automotive side, your vehicle called as edge. If you want to consider your mobile in the telecommunication side, there your mobile phone considered as a edge. Then what is edge computing? Edge computing is actually a distributed architecture. Okay, if you will see this, you will come to know what is edge computing it is. And you can say edge intelligence, and you can say edge AI. Edge AI is nothing about, it's combination of AI and edge computing. So what is edge computing? Edge computing is a distributed architecture that can save or process data in a logical way. That's all about the edge computing. So the edge computing also has a capability of placing the received data to the central data center. That's what I have mentioned here. So it can collect the data via base station. From there, it can keep finally the data in the central data center. That's called as edge computing. Okay. So that also put a data in the cloud storage repository, and the particular data will be used for the further processing. This is called as a edge computing. Okay, why we need a edge computing? So here I have shown that you have a micro DC, the traffic signal will communicate to your cloud, and the data will be pushed here in the data center, and it will be used for other purposes, and it can come via gateway, it can come via router, it can come via Wi-Fi access point, it can come via cellular, and it can come via micro DC also, right? So you can use any of the communication medium for to store the data in the cloud server. That's what I'm telling you. With the help of AI, currently IoT is in a different shape. Okay. Earlier IoT was little bit different, but now it's called as IoE, Internet of everything. Okay, right. Now, why we need a edge computing or edge intelligence? Why we really need a edge intelligence for your IoT devices? Because for bringing the great efficiency to take action, to quickly retrieve the data and to store the data in a cloud, we need some additional computing and stable solutions for IoT applications. You can say strong, scalable, and stable solutions for your IoT to store the data in cloud. So there we really need a edge computer. Okay. Do you know about the MQTT and HTTP protocol? That's also will be used in the edge computing. MQTT is nothing about message queuing, telemetry, transport, client server protocol. HTTP is nothing about, it's a one-to-one protocol. These all are is a communication protocol which will be used in the IoT world. Okay, you can use edge computing in healthcare. In healthcare, edge computing will be used in hospital and clinics to provide the better service to your patients. Example is Fitbit, wearable health monitor. So that's already having a capability to send the data even though you are in sleep, right? Clear? So you can use here in the sending a data, you no need to use cloud also, meaning directly go to your doctor and they can suggest it, right? So meaning best example for your cloud computing is smartwatch, fitness tracker, your glucose monitor, and other things also in healthcare. And in energy sector, obviously for the energy efficient energy production, we can use edge computing. And in agriculture, smart agriculture side, you can use actually edge computing. And commuting sector, you can use it for parking spaces, where it is parking spaces available or not, whether when you are going for a mall, so you want to know whether whenever you are entering into the mall, whether there is a space or not, then you can use edge computing. Okay, so is it really edge computing is needed in IoT? Yes, definitely it's needed because we have a good data security, the response time is too good, and enhanced resiliency. Because of so and so reason, you can actually use edge computing for your applications. Okay, got it? Right. This is the architecture which I explained now, how exactly the communication will happen in between your devices, how it is processed. And we don't have much time to discuss each and every things now. So these are the things you can refer. Okay, but this is what exactly about the edge computing. So when the edge intelligence as a word comes in the picture is actually whenever you want to involve AI, there you have to use the edge intelligence. Okay, getting the point? Edge intelligence, right? What is edge device? That's what I said. So wherever if you want to use vehicle for your edge network, that's called as a edge device. If maybe your router, your Bluetooth, your Wi-Fi, or your mobile phone, or your vehicle, so whomever is the entity, there it's called as a edge device. Right. Now, how we can utilize all these applications in industrial, in what that means, what's the purpose of IIoT, how it exactly this works in the industry, that's also you can easily get it. Okay, that means I will explain you. So IIoT is nothing about industrial IoT, industrial Internet of Things. Now think about it, all your tools, machines, everything is connected via network, and they started to act from within their side. That's called as industrial IoT. Okay, this image will explain to you about everything. Now, I'll explain it. What is a real requirement we have in industrial IoT? First one is cloud computing. Second one is you need to access anywhere and anytime. Third major important thing is security. Then big data analytics. Then user experience, asset management, and smart missions. You can think about any of the manufacturing industry, you really need all these things. You need a cloud computing. You want to access anywhere from anywhere else. Security, you need a security because you are transferring actually data from one machine to another machine, and you want to avoid the eavesdrop and all. That's where exactly you need a security. and big data analytics, because you can think about it, we have a 50 billion devices now. So how we will manage all the data when we push to cloud? There exactly we need a big data analytics. And user experience, the user experience is nothing about obviously your Android app. And asset management, you have a lot of assets. Assets is nothing about your computer, or it can be your manufacturing device, it can be anything, your router, or it can be anything. Okay, so in the case, if you want to manage all the assets, you need IoT. And when you want to bring normal mission to smart missions, that's what I told you. Normal auto, how it becomes smart auto for the Ola case with the help of IoT. The same way you want to say you want to have a smart missions, then that means normal mission to smart mission, then you need a IoT. Clear? Then what are the challenges we have? What are the challenges we have? The challenge is nothing about you need to have a precision of data. What do you mean by precision? The accuracy. So whenever you want to take a decision or whenever you want to send the data, everything need to be more accurate. Why we need to have a precision in the industrial IoT? You can think about it. There is a fire in the industry. Okay, in the manufacturing industry. They want to alert everyone immediately. If there is small delay or small latency, then in the case, this will create a big problem, very big problem. So we need a proper precision to take a decision, and adaptability and scalability. Because whenever the network is there, so whenever whatever the network we entered, everywhere we need to have a proper adaptability and scalability. So whenever you want to send the data between the devices, you need to manage in more security, because you need a security. That's the biggest problem in the IoT. Obviously, always there would be a problem whenever you are exchanging a data. So you need to maintain the security there. So you need a end-to-end security for whenever you want to transfer the data. Not only industrial IoT, wherever, even you are sending a message in WhatsApp, do you need a security or not? You need a security there. Otherwise, what will happen? If you will not have a security, we will not use a WhatsApp. We need to really maintain the security there. Got the point? There we exactly need a IoT, and that's also one of the biggest challenge to us. And you have to maintain it, and we have to have updates properly. Like your operating system, you have an Android OS. The Android OS, if you want to work properly, you have to properly maintain it, and you have to properly give the updates. That's what exactly for the maintenance and updates. And the flexibility. The flexibility is nothing about your IoT should be ready to work in all kind of environment. Then only you can manage and you can use it for your business purpose. That's what exactly about the flexibility. Okay, so these all are the general challenges we have in the industrial IoT. Now is a very important thing we used to call as a cipher physical system. So how exactly industry is currently working on it? Industry basically has a five standards. One is industry 1.0, 2.0, 3.0, 4.0, and 5.0. India is not ready to update with 5.0, but definitely will update in future. But Europe, Germany, kind of already well-established countries, they have started to work in industry 5.0. Industry 1.0 is nothing about in very earlier cases. Whenever in the world industry has started, there they have used mechanical terms. For an example, water and steam for the mechanical production, because there was no computer, there was no electronics, only we had a mechanical system. And after 100 years, after 1 century, industry moved from 1.0 to 2.0 with the help of electrical energy. Because in the industry 1.0, we couldn't make the mass production. The reason is industry has used water and steam. Say they couldn't produce the mass production there. But in the industry 2.0, there with the help of electrical energy, mass production made it. That was possible. The reason is assembly line. The reason is assembly line they have started with the help of electrical energy. After again 100 years, that means after a century, with the help of electronics, it's almost in the 1970, just 40 years back, we move to industry 3.0. There PLC kind of machines has evolved because we have started to use electronics, IT system and automated production, because that time the computer we have started to introduce, but very smaller one. That's about the industry 3.0. There exactly your PLC machine is for PLC we are using for manufacturing side. But after 30 years, this time we didn't take 100 years because of internet, because of your OS, because computer has started to evolve in the 2000. So there exactly we had a industry 4.0. There itself is called as cipher physical system. There IoT has started. Okay, and robotics, artificial intelligence. Might you can think about it. Do we have artificial intelligence in 2000? We have artificial intelligence in 1990 itself. Okay, and robotics, big data, cloud computing. There, that was the time of industry 4.0. That is cipher physical system. That's what we are calling as a cipher physical system. There, we have started to use IoT. Okay, now you got it. Where we exactly the industrial IoT, other things comes in the picture. That is in the early 2000. That's for with the help of Internet of Things, robotics, big data, and cloud computing. Now, in future, actually currently also we started. This industry revolution is like about 1G, 2G, 3G, 4G, 5G. We are in currently 5G now. Same way, industry 1.0, 2.0, 3.0, 4.0, and 5.0. So in the 5.0, we are going to have a humanoid robots, human robot co-working. Humanoid robots, might you all have seen the Robo movie. There in the role of Rajinikanth, how they made like robots with the same feelings of humans and everything. Such a kind of. That's humanoid robot. There exactly we'll have advanced AI, machine learning, and so many renewable resources. All major contribution from robotics. The industry will start to use maximum of robots for our mass production. That will happen in the industry 5.0. There we will use the advanced IoT. Okay, got it? Now, what's the main challenges we have in IoT? That means our topic itself, we are going to discuss about the research challenges. So now the industrial approach we discussed, but what are the research challenges we have? Why we industry feels, why the industry feels there is a challenge in IoT in the future? What kind of challenges we might will face? First one is security. Why security is a major concern we are feeling in the main challenges in IoT or in the research challenges? Security is always a concern. Even though we have a lot of secure mechanism, secure method, but even though when you are going to transfer many number of data, many number of devices which get deployed, we need to care about security. Security is nothing about security algorithm, AES, DS, RSA, ECC, cyber security, so many security mechanism, how both the devices are going to communicate with the help of an encryption, decryption, all other things will come in the big picture. That is a major research challenge in the industrial IoT. Okay, but really industry also doesn't know what kind of the security mechanism we are going to use it for industrial IoT or in future. Okay, next one is privacy. Privacy is about you are not going to deploy the devices only in your home. You can think about in the war field. You will deploy your IoT devices in the war field. So whenever in the war field your device is collecting a data, you have to maintain the privacy and you have to protect your data also. So depends on the application, everything will get changed. You can think about it. Tomorrow in future, your complete railway will use IoT, but there is no protection or there is no safety and security for your data. Again, what will happen is some malfunction also can happen. Malfunction means someone can eavesdrop your data. They can control the complete train also. in future. You know about the recent accidents, right? So they were also some of the devices might missed the IoT device. If they had it in the train, might they will come to know about the collision. So in future, what we will do, we will deploy IoT in all the trains and we can understand everything. But there is a problem also. When you are sending a data via cloud, if there is no proper security and safety and privacy, then what will happen? Then someone can eavesdrop your data and they can take a decision based on your things also. So that will lead to the big blunder in the communication mechanism. That's also one of the biggest threat we are feeling in the industry for the challenges in IoT. And another major one is power, the energy harvesting. I said you are going to deploy the devices in the war field. Who will give the power supply there? How you will get the power supply? It's very difficult to maintain via only battery, right? Then what are the other ways are there? How we can use a low energy protocol and computing? There exactly MQTT or Bluetooth low energy, everything is coming in the picture. So what is that actually? What is the low energy protocols are available? Otherwise, it will take a lot of power or drain from your battery. You can think now, if you want to use your mobile phone in the war field for IoT, do you really think it's possible? Maximum one day, your phone can hold a charge. Maximum 2 days, maximum 3 days, maximum to the maximum core. If you will not do anything in your phone, maximum the charge will hold in 3 days. That's what the problem in the IoT also. Because for our further development, for power supply, that's a major issue. There exactly we want to talk about LoRa, Sigfox, NB-IoT, and other topics. That's what exactly about the biggest challenges, research challenges we have in IoT. And majorly IoT is focusing on actuation, not only sensing. Actuation means you want to control a motor. That's what I took an example from the vehicle. See, sensing is what not only the work for IoT devices. You have to take a decision and you want to control your motor also. So you have to take for your actuator control too. That is one of the major challenge. And final challenge is the integration of AI and machine learning. When you are going to use artificial intelligence and machine learning, you have to be very careful. Why? That again will lead more power, because you need a chip of AI and machine learning relevant supporting chip in the IoT device. So when you are going to deploy your device in the war field, think about it, how exactly these all the things can be handled. Okay, these all are the research challenges we have when we are going to use IoT. Okay, what all are the IoT devices we have and what all are the IoT tools we have? For an example, if you are thinking about IoT tools, we have a many IoT tools and software for the usage in the IoT. The tools is like, for an example, you can use Arduino device, you can use ESP32, you can use NodeHU, you can use Raspberry Pi, you can use BeagleBone board, and when you are thinking about cloud tools, you can use ThingSpeak, you can use Core platform. Like that, we have a many. So what all are the programming languages we have? Basically, what are the programming languages we have? You can use Python, you can use C language, you can use many languages. Okay, and you can have a online circuit simulator, you have IoT scanner, you have a many things to perform. That's called as IoT core that you can use. And technology, when you're thinking about technology, you have a digital twin, you have a DevOps, and you have a many like kind of technologies. You can use it for IoT purpose also. Okay, so these all are the things are there in the IoT, and especially in the way of industrial IoT. Okay, and when you are thinking about industrial IoT, always it's lead to the industry 4.0. So how exactly IoT works in manufacturing industry. Do you know about that? How exactly, what are the applications we are using in manufacturing industry? So in the manufacturing industry, you can use it for cold chain monitoring. You can use it for products tracking tools, and maintenance in the workplace. There also IoT will plays a major role. So whenever you are doing the cold chain monitoring, there you can use IoT. You want to track the product, you can use IoT. Even now you are sending a courier. How exactly you are tracking your courier? How the thing is happening? That's also happening via IoT. Okay. So wherever you goes, we will have IoT. You're getting my point, guys? And you can start to work in IoT projects. We have a plenty of projects in IoT. Even by using very small Arduino, by using relay, you can completely control your lamp from your phone. And you can have a obstacle avoiding robot. You can have it. And you can have a smart energy system. You can have a heart rate monitoring system. You can have a automatic hand sanitizer dispenser. That means these all are simple projects. You can have a coal mine safety monitoring and alerting system. You can have a smart parking system. You can find it gas leakage, and you can do segregation of garbage and monitoring, and you can do virtual doctor consultation. You can do COVID testing center. You can have a home automation by using, you can use Arduino, Raspberry Pi or anything, and you can monitor the smart temperature and mask scanner. Whether you have weared the mask or not, that's also you can use by using IoT. Okay, so these all are the things are there. We are almost in the end of our session.